So we've been building up to the point where we can be able to start solving and working with equations, which is really the whole point behind algebra, right? Algebra is the tool used for solving equations, which is its main use. Now, you can do lots of other things with algebra, but this is the main thing you'll be working with. So we're going to start by talking a little bit about what it means to have an equation and what it means to solve them, right? We know that something is an equation simply based on something that it has. Something is an equation because it has an equal symbol. Now, you can call it a sign if you want to, but technically it's a symbol. What's a sign? Positive or negative. Those are signs, right? This is actually a symbol. But you'll hear it called signs. Even books, you'll see it written as a sign. Don't like it, but you know what? They don't let me do everything. Okay, so you know that something is an equation because it has an equal symbol. Anytime you see an equal symbol, then you realize that that is an equation. But there are all types of different equations in the world, and we're going to talk specifically about two in this course, right? So you need to be prepared. So the first thing I want to talk about is, what is a solution to an equation? Because many times students don't even realize what it is that they're supposed to be accomplishing. Okay? A solution is a number, and it can be numbers later, but right now we're talking about linear equations, so they specifically have one solution. A number that makes a mathematical...
True. Is it true?
Mm-hmm. A mathematical sentence true.
I was right.
You were right. Okay? Right? Now, if I started off with something really easy, just for an example, 4 plus something equals 6, what would you add to a 4 to make that equal 6? 2. So if you put 2 in place of that blank spot, right, then only a 2 would make this true. Do you agree?
Yeah.
Could you put any number, could you add any other number to a 4 and still get a 6?
No.
No. Okay? So, 2 is this, so if this were an equation, then 2 would be known as the solution for the equation. Now, but it would get a little inconvenient just to leave blank spaces, right, for your unknowns. So instead, we have a specific thing that we use in place of unknown numbers. What are they? The letters, which are called variables. Exactly. Okay? So you're going to be trying to get the variable to find out what number the variable represents, right? Because remember, those variables, we defined that before as just meaning some unknown number. Well, now our job is to find out what unknown number would make the sentence true. Okay? So you can have all kinds of equations and solutions. So let's just say we have 2b plus 3 equals, 7. We'll make it really easy. 2b plus 3 equals 7. And if I told you, I think that b is 3.
Incorrect.
How could I test that?
You go 3 plus 2 plus 2.
We'll just substitute. Remember substitute? That means put the number in place of the letter, right? But remember, when I put the number in place of a letter, I never replace a letter with a number without using a what? A bracket. Excellent. So 2 times 3 plus 3 should equal 7 in our scenario, right? 2 times 3 is 6 plus 3 is 9. And does 9 equal 7? No. So what does that tell you about the 3?
It's not 3.
It's not a what?
Solution.
Not a solution.
And it's supposed to be long.
It's not the solution for the equation. Okay? Now, what if I gave you b equals 2? Let's test that one. Again, how can I test it?
Substitute.
So in place of the b, I'm going to put a 2. Making sure to put it in a bracket. Order of operations says do the brackets first. So 2 times 2 is 4. And 4 plus 3 is? And does 7 equal 7? Yes. Therefore, the solution for this equation is 2. Okay? So b equals 2. So do you see that you can always test a solution by simply substituting, guys. By simply substituting the value they give you in place of your letter and working it out. Now, you could also have more than one letter. Okay? What if I had, this equation had been, we're not going to do this, 7 plus a. In order to test this, I would need to know a number for what? B, and a number for what? And a number for a. Okay? So you can have more than one letter that you're checking. Right? Okay. So, how do I know that something is an equation? Has an equal symbol. Excellent. And how do I know that some number is a solution to an equation? Exactly. It makes that mathematical sentence true. Excellent. Okay? Now, so what we're going to do is, we're going to learn the process that will allow us to find out any unknown number in an equation. And it is incredibly easy as long as you obey the rules in order. This is not one of those things that you can just glance at and hope for the best, right? Sometimes when the equations are very small, you can, but as they become more complex, it's going to cause you trouble. So we need to learn the process. And so that's what we're going to concentrate on today. We're not going to solve many equations today. We're going to look at some examples, of course, but what I really want to focus on are the rules. So the next time we meet, we will have a little test. And what do you think that test is going to be? The rules for solving an equation. Okay? All right? And then we'll do the homework where we actually solve the equation. I think it's so important that you understand the how. Okay? So here I go. All right. But we have something left. One more piece of background information. An equation is linear if you have no exponents on the variable. Now, did I just get through telling you don't have any exponents? No, you can have exponents. They just can't be an exponent on the what? The variable, which means the letter. So could I have x squared? Would that be linear? No. Y? Would that be linear? Yes, a plain old y would be. Okay? All right. How about x to the third power? Would that be linear? No. So it can be any letter. What you must not have are exponents. Okay? Now.
Can you have exponents on the plain numbers?
Right, because then you can just go ahead and solve that, can't you? I mean, you can just go ahead and multiply it out. So you can on numbers, but not on the variables. And the word linear comes from when these solutions are graphed, the graph of a linear equation would be a straight line. Okay? And that's why they're called linear.
That is what. Why is the equation linear?
Okay?
Because the lines.
But
If you have no exponent, and you graph these, it would draw a straight line, which that's what the equation, that's what happened to the equation, and that's why it's called linear.
Mr. Sal,
Yeah.
I've got a small cheesy question.
Okay?
Why do we have to learn all this math if the only place we're going to use it is to get a 6 on the math? Because, like, no, I should.
All right. So now we're going to talk about. All right. So let's talk about the steps for solving a what kind of equation? Linear equation. First of all, how can you tell it's linear?
If
No exponents on the variable. Of course you may. How do you know that something is an equation? Because it has an equal symbol. Good. So those are the two steps you'll know for how that it's a linear equation. Okay? Now, there are times when you can take some of these steps backward or in a different order. But in general, if you do them in this order, they will always work. Are there shortcuts sometimes for some things? Absolutely. Right? But if you don't know where you're going, can you use a shortcut? No. So keep that in mind as we go. Step 1 is to clear any brackets. You have to eliminate the brackets in order to be able to solve any equation. Right? But we always, the first step for anything is always get rid of what? Brackets. Excellent. Step 2. Now, this is something you haven't been used to because it's unique to equations. You're not allowed to just do this for any other reason, any other type of problem, but you can do it for an equations. We can eliminate any fractions. So, that should be good news. You are able to get rid of the fractions before you start solving the equations. So you won't have to have them all in the equations. Now then the bad news about it, though, unfortunately, is that you do have to know something about fractions in order to do this. Okay? So we're going to put the steps in, right? And this is fair game. The beauty is, though, it's exactly what I told you before. So what we're going to do is first find the LCD, right? Which is something that we've done before. That's why we looked at the fractions right before we started doing this. Second step, multiply every term by that LCD. Even if it's not a fraction. Okay, I'm going to write that down and then let me tell you something about linear equations that's too cool. Multiply every term by that LCD. So just the fractions? No, what? Everything, every term by the LCD. Okay? Here's the rule. You can do anything you want to an equation as long as you do it equally. Make sense? Equal symbol? You can do anything you want to. So could I add 7 to one side? Yes, as long as I also add 7 to where? To the side. Could I divide one side by 12? You bet, as long as you divide the other side by 12. So you can do anything you want to as long as you do it equally. So I can multiply by the LCD, but if I do, I have to multiply it times how many of the terms? All of them. The ones that have fractions and the ones that don't. Okay? Now, for the terms that do have a fraction, use the divide, then multiply pattern. Remember I told you divide by the LCD, multiply that result times the numerator. But when you do this time, what's going to happen is this eliminates the denominator. Because by the very definition of LCD, the denominator will divide evenly into it. And so if the denominator is gone, if you don't have a denominator, you also don't have you have a numerator, but you don't have a fraction, right? Isn't having a denominator the reason why it's a fraction?
Yeah.
Right? Otherwise, it's just a whole number, right? Or an integer. Okay? So what's going to happen is you can eliminate the fractions. Now, we're going to look at lots of these, but for right now, what I want you to focus on is the method. So focus on learning this process. Okay? You can tell me when y'all are ready, because I need to move the page to be able to. Okay. It's all right. It's okay. Just pause there. Again, guys. Okay. After you eliminate the fractions, the next step, the third step, has two parts, I'm sorry. Part A. Get all variable terms on one side. Okay? Now let's talk about what I mean by that. As you write, you can kind of listen a little bit. All variable terms on one side. So a variable term is any term that has a what in it? A variable or a letter. You bet. So if it doesn't have a variable in it, then it's a number term, right? So anything that has a letter in it needs to be on one side. And what I mean by that is on one side of the equal symbol or the other. Did I just say they always have to go to the right?
No.
Do they always have to go to the left?
No.
Do you think it makes any difference at all? No, otherwise I would have told you to put which side, right? So it makes no difference which side. Okay? Now, typically, we try to keep things positive because it's easier you make fewer sign errors if you have positives than negatives, right? Now, but you're all great at signs, so we're not going to worry about that too much. But if you're going to keep it positive, you can do that always by moving the bigger one. Right? If you have a 2 and a 4, if you subtract a 4, I'm sorry, moving the smaller one. I don't know what I'm thinking. Moving the smaller one. If you subtract a 4, what's 2 minus 4 going to give you? Negative 2. That gives you a negative. But if I subtract a 2 from a 4, what do I get? Positive 2, right? So if you move the smaller one, then you'll have better chance of keeping things from becoming negative. Now again, does it matter? Not at all. Right? So there are some students who want that variable term to be on the left-hand side of the equation no matter what. Who cares? And if you're one of them, I'm okay with that. Right? But we typically just move them to get things positive. Okay? Next, same step. If all of my variable terms are going one direction, what other kinds of things? I only have variable terms and what are they called? Starts with an N. Number terms. We're going to get all number terms on the other side. Okay. Mm-hmm.
You say that, then you get great grades.
Okay. All right. So get all your variable terms where? On one side. Get all your number terms where? On the other side, the opposite side. They need to be on opposite sides of the equal symbol. All right? Opposite sides of the equal symbol. But you need to move the variable terms first. You need to let your variable terms tell the number terms what to do. Okay? The variable terms are the important ones. That's the ones we're focusing on. And we're going to do that by using either addition or subtraction. What you're going to do is the opposite operation.
I'm pretty sure this rings a bell in my brain.
There you go. Look at that. So, if you're going to move an addition, so if a positive, if you want to move an add to, what is the opposite of add to? Subtract to. And I can subtract 2 from one side as long as I also subtract 2 from what? The other side. Okay? So what if I have minus 7? Subtract 7. What's the opposite of subtract 7?
Add 7.
Which is fine as long as I add 7 to what? Both sides. Okay? So you can do whatever you want to as long as you do it equally to both sides. So could I add 7 to one side? Yep. As long as I also add 7 to the other side.
What do you mean use
okay?
opposite operation?
So if it's plus 7, what's plus mean? Add. What's the opposite of add 7? Subtract. So subtract or minus 7. No, you do the same exact thing to the other, both sides. It's the opposite operation to how they're connected. You use the opposite to take things apart. Think about it. If you were going to put a screw in a hole, you turn the screwdriver one direction. How about if you're going to take it out? Take it the opposite direction, right? That's all we're doing. So you look at how things are connected and do the opposite. So if they're connected with addition, what operation will take apart addition? Subtraction. If it's connected with subtraction, what is the opposite operation of subtraction? Addition. So just look at how things are put together and take them apart by doing the opposite. Fourth and last step is to divide both sides. Again, remember, you can't do anything to one side that you don't do the other. Both sides by the coefficient of the variable term. Just write it down and then we'll talk about why. Divide both sides by the coefficient of the variable term. Okay? Because coefficient of a term is the number part, right? The coefficient is not another word for number. Coefficient is a fancy word for a multiplier. There you go, good. And if so that means they're connected with multiplication. And what is the opposite of multiply? Divide. So you're simply going to do the opposite, which is divide. Okay? And again, the reason we're dividing is because coefficients are connected to the variable by multiplication. Now remember, when we're talking about the coefficient, if it has a sign, we include the sign. Okay? All right. Okay? And once you've done that, that's the last step, then the variable is going to be completely by itself, and that's your job.
And then no more notes because it's something
Nope.
to make to single out.
If the variable, now did I say variable term here? Variable, just the variable, is completely by itself, and it better be, otherwise you've done something wrong, then the equation is solved. You're done. Okay? No worries. Okay? All right. So, all right. Let's look at a few examples of this so that you can see it in action. Just going to give you some very simple examples, but again, so that you can see it, because remember, in math, not only do you have to know how to do something, you also have to actually do it, right? Which is why everybody loves math so much. But we're going to talk about how to solve some basic equations. Now, I do not want you just calling out an answer, please. I need for everybody to be on the same page understanding this. And the only way I can do that is to make sure that when I call on somebody, they're the ones who answer the question. Right? So don't just sing out. Let me call on people, okay? All right. So we're going to start off easy. So before you start moving terms, combine any like terms that are on the same side. So let's make that a step 3. We'll make that step 4 and this step 5. That'll fix it, yeah. 2.5, perfect. Works for me, I don't care. Okay? You should combine any like terms that are on the same side. But make sure you've gotten rid of the brackets and the fractions first. Okay? So let's go back to our example. Now on this side, 3x minus 6, those are not like terms, are they? But on this side, 4 plus 7 are like terms.
Yes.
So I'm just going to bring down the rest of it. And 4 plus 7 makes what?
11.
So what you're doing is, it's those first 3 steps of the brackets and fractions and combining like terms are not designed to solve the equation. They're simply designed to get it ready to solve, to clean it up. All right, Tessa? Now, hello? I want to get all my variable terms on one side. How many variable terms do I have? One variable term, 3x, yeah? So if I only have one, is it going to move? No. Good job. Claudia, then I need to get all my number terms on the other side. How many number terms do I have? How many things that are just plain numbers? Two, right? Now my variable terms are on which side? So my numbers need to move to the right. Okay? So which one of those two numbers is going to move then, Claudia? The negative 6, right? Make sure you put the sign with it. Good, good. And how do I move subtract 6? The opposite of...
You add 6.
And if I add 6 to that side,
You have to add 6 to the other.
there you are. Now over here, the 6's are going to subtract away. Gives me just my 3x. On this side, 11 plus 6 is 17. It's getting awfully noisy in here, guys. Okay?